So the name of the game in this section, we're talking about arithmetic sequences and series. We've got two goals. Goal number one is to find the nth term of an arithmetic sequence. Now what that really means is you want a formula for the nth term where n could be a counting number, 1, 2, 3, 4, blah, blah, blah. So if you want, if you want a 100, you have a formula. I'll use the function notation that you're used to. And you could plug in 100 in where n appears in the formula. That's if you have an explicit formula, right? So we want to find an nth term formula. So in general, it'll be in terms of n, and we represent that by a sub n. So we want to find an nth term formula so that we can find the nth term of an arithmetic sequence. That's goal number one. Goal number two, to find the sum of the first n terms of an arithmetic sequence, which is also going to involve another formula. So at the end of last time, I showed you how to do one like this. So take a look at the sequence. We want to find a formula for it. 2, 7, 12, 17, and then presumably it keeps going, right? So dot, dot, dot. Do you notice anything special? Now, here as humans, we think recursively. We look for patterns, right? And it's actually quite a skill we have to look for patterns. Sometimes we're wrong, by the way. Sometimes we think we see a pattern that's not there. I made a mistake about 10 years ago, and I bought an acre of land. Why was it a mistake? It's a lot to take care of. It sounds great, right? You got space and stuff, but it's a lot to take care of. Anyway, when I'm walking around on the land, because you got to clean it up all the time and work on stuff and trim trees and stuff. When I'm walking around on it, sometimes I see out of the corner of my eye, a little wiggly thing. And I go like that. And it's a stick, and I feel dumb. But why did I go like that? Because I pattern recognized what could be a snake, right? I was wrong, but it's pretty important to recognize a snake when it's there. And if you mistake a stick for a snake, is it a big deal? No. So it's pretty important that I have that pattern recognition. As humans, we're really good at pattern recognition. But again, sometimes beware, we do make mistakes. I see a pattern here. Do you guys see it? What is the pattern? If you look at the difference between each successive term, again, this is recursively thinking, we see that the difference is 5, don't we? So 7 minus 2 is 5. 12 minus 7 is 5. 17 minus 12 is 5. So you repeatedly add 5 to go recursively from one term to the next, don't you? So what is repeated addition of 5 associated with? Multiplication. So I showed you the trick last time that a sub n, okay, it won't be 5n, but it'll be some variation of that, unless it starts at 5, right? It won't be 5n, it'll be some variation of 5n. You have to adjust it so that the first term comes out to be 2. And we're assuming n starts at 1 here. So if you plug in 1, a1 equals 5 times 1, 5, if I just leave the formula as is. So how do I have to adjust it so that I get 2 popping out? Subtract 3. And that's it. Now you can test it, right, to make sure it's right. And you should test it. So try the next couple. If I plug in 2, do I get 7? 5 times 2 minus 3, 7. Yeah. If I plug in 3, do I get 12? 5 times 3 minus 3, 12. Yeah. So I'm positive I got the right answer. So that was using recursive thinking to get the explicit formula. And that's a perfectly valid way to do it when it comes to this sort of sequence. So why did I mention this sort of sequence again when I showed you an example like this the other day? This kind of sequence is what we're studying in this section. It's called an arithmetic sequence when you generate the terms by adding a common difference between each term. Does everybody see why we call it the common difference? If we subtract any term, well, from any term, the term that comes before it, we get the same thing. So it's a common difference. But then to generate the entire sequence, if that were possible, you could start at whatever the starting point is, keep adding 5. So you add the common difference to generate the terms in the sequence. Yes? There are no stupid questions. I have plenty of stupid answers, though.
Why wouldn't you just add 5? Why do you have to multiply by 5 and then subtract 3?
You would if you want a recursive sequence. So recursively, this is, remember, this is explicit. When I was a kid, explicit meant, you know, bad lyrics. So we'd go to the music store. Yeah, they used to have music stores. And we used to buy either tapes or actual albums, records. And if it said explicit lyrics, oh yeah, that's the one we want to buy. But that's not what that means here, right? You guys have no idea what I was just talking about, right? What's a music store? Okay, so explicit, it means plug and chug formula, right? If you want the 100th term, what do? Plug in 100 for n, and you got 5 times 100 is 500, minus 3, what, 497. There it is. Could do it in my head. And believe me, I'm not that good at arithmetic. Even I could do it in my head. What's the problem if you want to just keep adding 5 to get to the 100th term? You got to keep adding 5 to get to the 100th term. That's the problem, right? So you got to find the first. You got to find the first 99 terms, right? You got to. That means you need to find the first 98 terms, and so on and so forth. That's recursive thinking. Now there is a formula recursively. As long as you state what the starting value is, a1 equals 2, the recursive formula would actually be an equals. Okay, so there's a couple different ways to represent it, but you could say it's an. Well, okay, what do you do to the nth term, or the term that comes before the nth term, rather, to get to the nth term? What's the term symbolically that comes before an? What is it? It's an minus 1, right? That's the notation. So the subscript tells you where you're at if you were listing all the numbers at, right? So this is a1, that's 2. a2 is 7. a3 is 12. The subscript tells you where you're at in the list of numbers, right? So what do I do to the term that comes before whatever the nth term is to get the nth term? What do I do to a sub n minus 1? I add 5. So there's what you were talking about, and it's perfectly valid. This is a recursive definition. It's just, or a recursive formula. And it's just we prefer the explicit formula when it's easy enough to get anyway. But really, we think this way. We really do. I mean, we recognize the pattern this way. We think recursively. We are recursive creatures.